Here is a typical IV characteristic of PV module. In a bright sunny day, the irradiance is about 1 kilowatt per meter square. But when it's cloudy, it can be as low as 100 watt per meter square. And this curve shows you the module current with respect to the voltage. So in a standard test condition for solar module is defined as the operating temperature of 25 degrees Celsius, solar irradiance of 1 kilowatt per square meter, and the atmospheric density of 1.5. And this is considered as a bright sunny day with a moderate temperature. However, in realistic, the operating temperature is high. It can be as high as 45 degrees Celsius. And if you consider the cloud and wind, the solar irradiance may be degraded. So those normal operating cell temperature is defined, the testing condition is defined as 800 watts per square meter, and with the same the atmospheric density of 1.5. So the overall performance is about 85 to 90% of STC. It is a more realistic field conditions. So typically in the spec of the module, you may have the spec given in these two conditions. And here is another example, which is the Panasonic PV module. So the rated power, which is P maximum, is 340 watts. And you can see several numbers, for example, maximum power voltage, maximum power current, open current voltage, open circuit voltage, or short circuit current. So let's take a look at the IV and PV characteristics of PV module. So the orange line represents the IV curve. From the curve, on the right-hand side of the voltage, which is the open circuit voltage. Since it's open circuit, the current is equal to 0, but the voltage is the maximum, which is, in this case, is 71.2 volts. And the other term is called short circuit current. Since it's short circuit, so the voltage is equals to 0, and the current is the highest one, which is 6.02 amp. And then you can multiply the voltage and current to have the power with respect to the voltage. So you can see that there is a peak or the maximum output power. So we represent that this power is P sub MP. And this maximum power, the voltage in this case is 60.3 volt, and the current is 4.64 amp. So if you multiply these two terms together, you will get the maximum output power. In this case, is equivalent to 340 watts. And from the data sheet, you can also find the IV curve with respect to irradiance. So the current is almost linear to the irradiance. However, the voltage stay almost the same. And there's another important coefficient, which is called temperature coefficient. It is quite important because the output power is degraded at high temperature. So we have negative temperature coefficient for Pmax and also the voltage. Although we have positive coefficient for the current, the overall output power still have negative temperature coefficient, which means that in the bright sunny day, although you have more power generated, but due to the temperature coefficient, which is negative, then the power will be degraded. So from the data sheet, you can also see there's a module efficiency, and we can actually calculate the number according to the spec. So first of all, we need to define the efficiency. The efficiency is the power output divided by the power input in percentage. So to get the number, first of all, we need to figure out the area of the solar module. And here in this table, we have the dimension. So you have the length and width. So the overall area is 0.674 square meter. And then we calculate the power. Since the overall power, the maximum power is 340 watt, and then you divide it by the area, you get the output power, which is 203 watts per square meter. And remember that for the standard test condition, the input power is equal to 1 kilowatt per meter square. So calculate the efficiency, you get the overall efficiency is 20.3%. Okay, so this concludes the lesson of this section. And if you are interested in the material and you want to have further study, here are the references. Okay.